In this session, we're going to talk about Hyperledger Fabric and specifically the open source distributed ledger technology that the Hyperledger Fabric Foundation and the Linux Foundation has been contributing to. We're going to talk through some of the core architecture of what makes up Hyperledger, why it's important in this space, what are some of the nuances or differences between it and some of the other popular offerings like Ethereum and Corda and such. And then we're going to talk a little bit about the data flow, and then I'll walk through a short demo to show you spinning up a network. We'll share the code so you can go through this yourself at your leisure. But I wanted to actually show how this actually functions and where we'll actually do a transaction via chain code on there as well. So to start off, the core architecture for Hyperledger is quite a bit different from some of the other technologies that exist out there. It's very much focused on a need to know for transactions, so a peer-to-peer type model, particularly for chain code. And so the nodes are essentially two different types. There's peers that exist on this network. These peers can be what we call endorsing peers or just regular peers. And when I say endorsing peer, it means someone who can make changes to the ledger. So peers have to be elevated to that right. They have to be granted that right specifically and explicitly. And so this is part of the permissioning that exists in Hyperledger to control access to the network. This is not a trustless network. This is something very focused on enterprise and very focused on security and a need to know on transaction basis. And so basically after we have our endorsing peers, we also have the orders. Now the orders are essentially form the consensus model that Hyperledger employs. Now currently for production type workloads, we use a Kafka-based cluster. So if you're familiar with that open source technology, that is actually used, and we basically build a network of ordering nodes, which, based on the name, it essentially means they're ordering the transactions that are going to exist. And if you can control the ordering of transactions in a ledger, you can control the ledger. So this is essentially the point that is a central point for this whole network to run this Kafka cluster. The peers must be onboarded, as I mentioned, through this permissioning, and they can be endorsed or non-endorsed. Now, if we talk about the data flow a little bit, if you look at this diagram, basically what we're showing here is the peers themselves are basically going to be signing transactions from the application. There's going to be an inspection that happens in the middle here, and that's our verification. And then there'll be the ordering service, which is going to order those transactions. So, there's a different data flow here as opposed to some of the other chains, but it's still structured around the notion that we have this peer-to-peer network that is using digital signatures, very strong KYC on these people. So anybody who's existing in this network and who is signing things has essentially a CA behind it. A CA is a certificate authority, which generates certificates, and this is how we build trust in this network. So participant A will say, here's my certificate that validates who my identity is. The other participants will agree on that. He can then be used to sign transactions, endorse peers, depending on his permissions in the network, perform those type of operations. Now, to go through this and show a little bit of a demo, what I did was set up a box over here, and you can do this yourself. We'll share the code. Essentially what I have in Azure here is a box, and I was going to walk through setting this up manually, and here's just part of the setup. So you can see there's quite many commands that you have to run here to set this up. There's some baked-in tools that they have for crypto generation, for certificate generation, for the transaction generation, setting up all these different peers and orders. But what we're going to use is one of the scripts provided by the Fabric guys, who basically have created this bootstrapper here. And this will help you get started as you first getting used to how you run these kind of networks. So in this case, I'm basically going to run this command to go ahead and spin this up. Now what I have here is an Ubuntu box that's basically running Docker. That's pretty much all that's been installed on here. A few of the binaries from Fabric have been installed on here as well for the crypto gen and the certificate stuff. But basically that's what I have. And you'll see the screen scrolling. I'll scroll up here in a second once it's completed. But what's happening here is basically we're setting up multiple organization here. And what are orgs? Orgs are the participants in the system. So anybody who joins into the system as a separate participant, we'll call it, is what we traditionally call them. They're called orgs in Hyperledger. So when you see org, think about that. MSP is the service provider for the identities. So just keep that in mind when you see MSP. Peers are obviously these things that are going to orchestrate these transactions and endorse transactions or verify them. And then the ordering is what we mentioned before. Now this is still going through. It instantiated some chain code here. It's going to complete a transaction here. As I mentioned, we'll scroll through this. But the idea is like it's a little overwhelming when you first get started with this to look at kind of how this setup actually happens. We actually have templates in the marketplace, Azure Marketplace, to help you spin these up as well to make this as easy as possible. I'm kind of pulling away some of the infrastructure because a lot of this code is infrastructure. Now, the code that gets specifically executed as like a smart contract traditionally is called chain code in Hyperledger. And chain code, again, is specifically targeted to peers. So we don't have like a kind of global broadcast happening here like we would have with something like Ethereum. And so in this case, basically this is attempting the chain code right there. We'll let that complete. It looks like it is completed. And we'll basically jump up here and take a look at what happened really quickly. So when this thing bootstrapped, basically it created two orgs here. You can see it generated the Genesis block. It created channels. Now channels are basically those relationships between the peers. So that's how we're going to orchestrate our transactions. That's what we're going to target chain code with. We're going to say, hey, we have some chain code. We want it to run on this channel. That channel defines what peers have access to it. So again, need to know basis of who has access to the data that's being orchestrated, the state that exists on the chain and whatnot. Anchor peers are these guys who basically are going to help run the network. So as we mentioned before, and then basically what we did is you can see it was spinning up the Docker containers. After that, we're basically going to kind of initialize our peers. And you'll see down here, basically peer 1 and peer 0 was being joined into the network. And then the anchoring was happening here. They're being approved. And then we see chain code is actually being run on here. So we installed some chain code, which basically can be written in Java, Go, or Node right now. So you can set these up in different forms. And then we can see that we actually ran a transaction down here. So we queried the channel down here again to see what was going on. We invoked a transaction successfully, and you can see the output here. In a short time, we couldn't drop through everything that's happening there, but we will have these scripts available so you can go out there and take a look at how this stuff actually, what's happening behind the scenes in detail. But this kind of just gives you a taste for how Hyperledger works, how to get running with it. Again, we'll share the code and the pointers to the tutorials, but I hope that you learned a little bit about Hyperledger in this, and thank you.